Parallel lines cut by a transversal. A transversal is a line that intersects two or more coplanar lines, each at different point. For example, we have these two coplanar lines, and if we use a line to cut these coplanar lines, this red line is what we call transversal. Transversals play a role in establishing whether two or more other lines are parallel or not. Look at this figure on the right side. So we have here parallel lines cut by a transversal. The intersections of a transversal with two lines create various types of pairs of angles. Let us enumerate it one by one. Let's start with grouping these angles into two, which are the interior angles and the exterior angles. For the interior angles, of course, those are the angles inside the parallel line. So we have here angle 3, this one, angle 4, angle 5, and angle 6 as our interior angles. And then for the exterior, of course, these are the angles outside the parallel line. So we have angle 1, angle 2, angle 7, and angle 8. Now, let's proceed with the pairs of angles formed by the transversal. First one, we have pairs of corresponding angles. When we say corresponding, for example, we have this angle 1 and we are looking for the corresponding angle of this. You just have to look at the angle with the same position as angle 1. So, if you will look at angle 1, it is in the upper left part of this set of angles. So, therefore, we have to look also for the upper left part of the second set of angle. So, we have here angle 5. It means we can pair or we can say that angle 1 and angle 5 are corresponding angles. What else are the corresponding angles we have in this figure? It can be 2 and 6. As you can see, they are both in the upper right. Then we also have 3 and 7. So 3 is in the lower right. Also 7 is in the lower right. So they are corresponding. Then lastly, we have 4 and 8. So where is 4 and 8? So let's see where is 4, this one. It's in the lower left and 8 is also in the lower left. So they are corresponding. The next pair we have here, pairs of alternate exterior angles. So when we say alternate exterior, we will just be looking at angle 1, angle 2, angle 7, and angle 8. The angles that are outside this parallel lines. So when we say alternate exterior angles, if for example, your first angle is angle 1, since angle 1 is in the upper left, the alternate angle will be in the lower right, which is the angle 7. So we can pair angle 1 and angle 7 as alternate exterior angle. What else? Of course, the other two angles. We have angle 2 and angle 8. If we have alternate exterior angles, we also have alternate interior angle. But this time, we will just be looking at the angles inside these parallel lines. So, if, for example, we have 4, it can be paired with 6. They are alternating angles. While the other one, we have 3, we can pair it with 5. So we have 4 and 6, and 3 and 5 for the alternate interior angles. Next pair of angles, we have pairs of vertical angles. If, for example, we have intersecting lines, we have angle A, B, C, and D. Vertical angles here are A and C, the opposite angles. And then B can be paired with angle D. So they are also vertical. In our illustration here at the side, the vertical angles we have here are angles 1 and 3. So this one, they are opposite. We also have angle 2 and 4. Here angle 2 and here is angle 4. Also, we have 5 and 7. They are vertical angles. And the last pair we have are angle 6 and 8. They are also vertical. Then, the fifth one, we have pairs of angles on the same side of the transversal. So when we say on the same side, for example, they are both on the left side or they are both on the right side. So for angles on the same side, it can be in the interior or it can be in the exterior part of our parallel line. So for the interior part, we have here 3 and 6. You look at 3 and 6, and they are both on the right side. And then the other pair we have are angle 4 and angle 5. They are both on the left side. Okay, that is for the interior angles. Then for the exterior angles, we can pair 2 and 7. They are both in the exterior. Also, they are both on the right side. So they are angles on the same side. Also, the other pair are 1 and 8. Both are on the left side. And to prove that the lines being cut by a transversal are parallel, angle pair relationships were created. First one, we have corresponding angles. They must be congruent. It means they must have the same measurement. Same with alternate exterior angles. They are also congruent. Alternate interior angles are also congruent. Vertical angles are also congruent. And the last one, we have same side interior or exterior angles. They must be supplementary. So among these 5, only same side interior or exterior angles are supplementary, or the sum must be equal to 180 degrees. We may also include here the linear pair. When we say linear pair, if there's a straight line divided by another line, the two angles formed are supplementary, or the sum must be equal to 180 degrees. For example, this one is 40. Automatic, the other one must be 140 degrees because their sum must be 180, or they are supplementary. So let's discuss it one by one. Corresponding angles are congruent. What are the corresponding angles in this figure again? First, we have 1 and 5. So it means if, for example, angle 1 measures 120, automatically angle 5 will also have 120 degrees if they are parallel lines. What else are our corresponding angles in this figure? So we have 2 and then 6. We also have 3, this one, and 7. And the last pair we have 4 and 8. So again, for example, whatever the measurement of angle 4 is, for example, this one is 30, angle 8 must also be 30 since they are congruent. When we say congruent, they have the same measurement. The second property we have, alternate exterior angles are congruent. So here in this figure, the pairs of alternate exterior are angle 1 and 7 and angle 2 and 8. So for example, angle 1 measures 100 degrees. Angle 7 must also be 100 degrees since they must be congruent. 1 and 7 are alternate exterior angles. Next, alternate interior angles. They must also be congruent. In this figure, our alternate interior angles are 3 and 5. Okay, and then 4 and 6. So if 3, for example, measures 150 degrees, angle 5 must also be 150 degrees because 3 and 5 are congruent. We also have vertical angles are congruent. Pairs of vertical angles we have here are angle 1 and 3, angle 2 and 4, angle 5 and 7, and angle 6 and 8. So they are the opposite angles like this. Angle 1 and angle 3, angle 2 and angle 4, angle 5 and 7, and angle 6 and 8. And it says that they are congruent. So if, for example, angle 1 again measures 120 degrees, angle 3 must also have 120 degrees as its measurement. And the last property we have is same side angles are supplementary, or the sum must be equal to 180 degrees. What are the same side angles we have in the figure? First, 3 and 6. So when you add the measurement of angle 3 and angle 6, the sum must be equal to 180 degrees. Same with other pairs like 4 and 5. So 4 and 5, they are same side because both are in the interior and on the left side. So their measurement must also be equal to 180 degrees. And we also have angle 2 and 7. Angle 2 and angle 7, they are both on the exterior part of the parallel lines and also both are on the right. Their sum must also be equal to 180, and also angle 1 and angle 8, their sum must also be equal to 180. So for example, let's use 3 and 6. If angle 3 measures 150 degrees, what must be the measurement of angle 6? Of course, since they are supplementary, what you have to do is to subtract 150 from 180. You'll get 30 degrees. So the measurement of angle 6 must be equal to 30 degrees. To recheck your answer, you may add these two measurements. So 150 plus 30, as you can see, your answer will be 180. So they are supplementary.
Let us now have an example. Again, we have here parallel lines cut by a transversal. Given that the measurement of angle W is equal to 162 degrees. So let us write here 162 degrees. And then with that given angle, we will be looking for the measurement of the rest of the angles given. Let us start with angle M. So angle M is over here. And since the only given we have is the measurement of angle W, we will be using 162 to find the value of M. Observe, look at angle W and angle M. What is their relationship? Are they corresponding, alternate, vertical, or same side? Okay, as you can see, angle W is in the upper left. Same with angle M, it's also in the upper left of this set of angles. Therefore, angle M and angle W are corresponding. They are corresponding angles. Since they are corresponding angles, it says that corresponding angles are congruent. So it means the measurement of angle M must be the same with the measurement of angle W. So it will also be 162 degrees. So let us write 162 degrees. Next, how about the measurement of angle Z? In the figure, angle Z is here. This angle C, we may pair it with angle W or angle M. For example, we will be using angle M to find the value of angle C. So look at these two angles. What is their relationship? Corresponding, alternate, vertical, same side? Okay, they are alternate interior. So angle Z and angle M are alternate. Since they are alternate interior, they must also be congruent. Same with corresponding angles. They are also congruent. Therefore, the measurement of angle Z must also be the same with the measurement of angle M, which is 162. Okay, so angle C is 162 degrees. Next, let's look for the measurement of angle N. Where is angle N? Over here. So we may pair it with any of these three angles. We may pair it with W or Z or M. For example, we will use the measurement of angle Z to find the measurement of angle M. Observe, Z and N. What is their relationship? Angle N and angle Z actually are same side interior. Since they are same side interior angles, then they must be supplementary, or the total measurement of their angles must be equal to 180 degrees. Therefore, to find the measurement of angle N using angle Z, which is 162, you have to subtract it from 180. So we'll have 180 minus 162. 180 minus 162, you'll have an answer of 18 degrees. So therefore, the measurement of angle N is 18 degrees. Next, how about angle Y? Where is angle Y? Over here. Okay. It is easier to identify the measurement of angle Y if we will pair it with angle N, because angle Y and angle N, they are alternate interior. So they are alternate. And for alternate interior, they must be congruent. So therefore, the measurement of angle Y must be equal to the measurement of angle N. So it must also be 18 degrees. Let us write 18 degrees. Okay, next, how about measure of angle O? Where is angle O? Over here. Okay, we can pair it with any of these angles, but it is easier if we will pair it with angle N. Look at angle O and angle N. As you can see, angle O and angle N, they are vertical angles. Since they are vertical angles, then they must also be congruent. So angle O and angle N are congruent. Therefore, the measurement of angle O must also be 18 degrees. Same with angle N. Next, what is the measurement of angle X? Where is angle X? Over here. We can pair it with Y, since X and Y are vertical. So angle X and angle Y are vertical. And we know that vertical angles are congruent. So therefore, the measurement of angle X is the same with the measurement of angle Y, which is 18 degrees. So we have 18 degrees for X. And the last one, angle P over here. So again, the easiest way to find the value of P, you may just look at angle M because they are vertical angles. So therefore, the measurement of angle P is also 162 degrees. Okay, now we have completed the measurement of all of the angles. And actually, if you will observe carefully, look at their measurement, starting with the given measurement, which is 162. They are just alternating. So we have 162, then 18, then 162 again, then 18, 162, 18, 162, 18. So it means if you have one given angle, just subtract it from 180, you will be able to get the angle beside it. Then write it alternately. 162, 18, 162, 18, 162, 18, 162, 18. Okay, you can only apply this if the lines cut by the given transversal are parallel.